Hello, good day, engineers. Once again, you're welcome to Joxford Engineering Academy, where we train future civil and structural engineers from basic to pro. My name is John Anuadun, and I am your instructor for today. Today, I'll be taking us on how to calculate for your wall unit weight and also how to calculate for your block wall load. Okay, in our last class, you remember I taught us on how to apply your wall load in your product structural environment. You can see this is the project we did in our last class where I taught us on how to assign and apply your wall load on this your structural beam element. So now I'll be taking us through for us to also have a view of where we did our loading again. Okay, so that's fine. So when you come to this environment, let me go back. When you come to this where you load your where you did your wall load application, click on the structural beam element, right click on it to highlight it, left click on it, and come to edit loads. You see edit loads. Click on edit loads. So after clicking on edit loads, I told us I'm going to take us on how to apply all of these other loads, but now for the purpose of this class, we are looking at your wall load calculation. So you click on your wall load and you see the input parameters that we defined, for this residential building. I told us, if you remember in our last class, that for a 9 inches block wall, which has a width of 225, that the wall unit weight is 3.47. Now, in this class, I'll be showing us on how to calculate for this 3.47 kilonewton per meter square, so that in case you are also designing for a building or you want to calculate for a wall load of maybe 150 or 300 or 400 size, 9 inches, 12 inches or thereabout, you understand, we have some special blocks that also comes in those sizes. Maybe you want to design for maybe a block wall size of a 150, or you want a block wall height that is greater than this 2.7 meter. You can also know how to go about it. You understand? Because that's one good thing about Joxford Engineering. We show you everything. We show you about the calculation aspect. We show you the application aspect. So in this class, I'll be showing us on how to calculate for this value, which is your 3.47 kilonewton per meter square, which is your wall unit weight, and also how to calculate for your wall load. This is your wall load. You can see that the wall load value for this height, 2.7 meter height, is 9.369. Okay, that's fine. Now, somebody asked me in the last class, how did I get these values? Was it by assumption? I said no. These values are actually calculated. You understand? So they are dependent factors on the density of the block you're working with. Now, let me take us through the calculation. Okay, let's go. All right, you're welcome. So here we are. You can see before us is a sketch. I did this sketch so that we all can have a first-hand view of the illustration. Now, for a 9 inches block wall, this is a 9 inches block wall. This is a 9 inches block wall. Once you see a block wall width with a 225 millimeter, which is 0.225 meter, 225 millimeter, know that it is a 9 inches block wall, and the length is 450. The height is 225. Then you can see for this hollow block wall, this one now is for a hollow block. This hollow block from this point to this point is 50. 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 Then from there, you can also calculate for the size of your hollow if you want to calculate for that. But that's not our point now. Here, we are designing for a block wall load of 9 inches for a residential building that has a headroom. The headroom for our residential building here, you can see, is 3 meters. This is our design information. We are given a residential building of 3 meters headroom height to design for, and our beam section for that is 0.225 by 0.450 meter. You can see that beam section. Let me show you in our structural model. So what I mean by our beam section the beam section, which is this one. This beam section is 225 by 450. Now, okay, if you come to this place, which is a 225 by 450. All right, our slab thickness is 0.15. This is our design information, our given data. Then the block wall size, you understand, is 9 inches. Now, the width of a 9 inches block is 0.225 meter, you understand, which is 225 millimeter, you understand. So you convert this to meter, you're going to get this. Then that's for hollow block. You know, it's not a solid block, hollow block. Now, the density of a 9 inches hollow block, this is the density of a 9 inches hollow block, is 15.4 kilonewton per meter cube. Mind you, I told us that for a hollow block, the 1 unit weight is different because of this hole, this vacuum, this space, this void here. Because of the void, the 1 unit weight for a hollow block is lesser than that of a solid block. If you're actually designing for a solid block, you're going to have your 1 unit, your density, the density of a 9 inches solid block is going to, it ranges from 18 kilonewton per meter cube for solid block 9 inches, ranges from 18 kilonewton per meter cube to 21 kilonewton per meter cube. But for the purpose of this class, we are treating a hollow block. So for a hollow block 9 inches, take it from me that your density for a 9 inches hollow block is 15.4 kilonewton per meter cube. Okay, now, how do you calculate for your 1 unit weight? Remember, I told us in this place that our 1 unit load, our 1 unit weight is 3.47, which is this value. You can see this 3.47. How do you calculate for it? Come back to this place. You're going to see when you want to calculate for your unit weight, the formula for your unit weight is volume times density. Your volume is your length times the width times the height. You understand? Which is in meter cube. Your length is in meter, your width in meter, your height in meter. You understand? So meter times meter times meter is going to give you 3 meter. Meter times meter times meter, which is meter raised to power 3, which is meter cube, times your kilonewton per meter cube, which is the unit for your density. Now, if you check in this place now, it is the unit for our unit weight is in meter square, which is, you know, square is length time breadth, which is meter square, length times breadth, which is meter square. So we are going to be taking it in meter per meter per meter. So this 1 meter times this 0.225. Now somebody can ask, in my last class somebody was asking me, where is this 1 coming from? This 1 is coming, this is the length. You're checking what is the unit weight of 9 inches block per meter run, which is 1 meter. So which is this 1 meter? So the length we are checking, because we are checking it in per meter, the unit weight of 9 inches in per meter, we take 1 meter length. Then for the width, you now use the width of this your 9 inches block, which is 0.225, you understand, which is this value. So now the height, which is this one, I told us your unit weight is in meter cube, your meter square rather, which is length times breadth. So your length is 1 meter, your width is your 225. We are checking also our height in 1 meter because we are checking the unit weight per meter run. So you define it and check the unit weight per meter run. Length 1 meter, width 0.225. If you're checking for a 6 inches blocks, 6 inches blocks has the width to be 150 millimeter. You have to change this your width to 150, which is 0.150 meter. So you can see that in calculating for your unit weight, your depending variable is the width, which is this W, the width, you understand, because you're checking for per meter run. So, but in this case, we are checking for a 9 inches block. That's why you see that we have the width of a 9 inches block in this place. Then 1 times this, 1 times 0.225 times 1 meter is going to give us 0.225. If you say 0.225 times 15.4, it's going to give you 3.465 kilonewton per meter square. You understand? So you can round this up to 3.47. So that's how you calculate for your unit weight. That's how you calculate for your unit weight. Then you come to your block wall height. Your block wall height calculation is simply your beam depth. Your beam depth we have here in this section that our beam section is 0.225 times 0.450. You can see here. Now, our beam depth is 450. Our width is 225. Then to get your drop down beam, you subtract your slab thickness from your beam depth, which is 0.450 minus 0.15 in meters, which is going to give us 0.3 meter, which is 300 millimeter. So our drop down beam, therefore, our drop down beam in this case is 300 millimeter, which is this 0.3 meter you're seeing. Permit me, I'm going to be using the units interchangeably. You understand? For us to understand clearly. You understand? So now, our block wall height is equal to our headroom height minus your drop down beam. Our headroom height is 3 meters and our drop down beam we've already calculated here by subtracting our slab thickness from the depth of our beam to be 300. So headroom height minus drop down beam equal to 3 meter minus 0.3 meter, which is going to give us 2.7 meter. That is how we got the value that we applied in this place. If you come to your edit loads again, you're going to see, come to your wall load, you're going to see this value, which is this value 2.7. You understand? If you see here, there's an indication showing you your H, showing you your H. So this is your H calculation. Your H start is 2.7 meters. You understand? From one end to the other, they are equal. It's not as if it's not an unequal block wall. It's not a slender block wall. So it's an equal block wall. So you put it this way so that it will calculate the load for you. So that's fine. If you come to this place, you see this is a 2.7. Okay, that's how we got this value. Now, your block wall load calculation, you understand? Wall load calculation is your wall unit weight times your block wall height, which is, we've already calculated our wall unit weight in this place to be 3.47. Then you multiply this 3.747 by 2.7, which is your wall height, is going to give you this 9.369 kilonewton per meter. So, which is this value you're seeing here. If you come to your edit loads again, you come to your wall load, this is, which is this value, 9.369. This is how this value is calculated. You understand? So, this same approach, you can use it in case your wall height is changing from 2.7 to any other height. You can use the same approach to calculate for your block wall unit weight, block wall height, respectively, as the case may be. Okay, so thank you very much. This is the end of today's class. Once again, you're welcome to Joxford Engineering Academy. Please click on the subscribe button and subscribe to our channel so that you can be getting our notifications once a new video or a new video on any structural element is out. So thank you. Don't forget to click on the subscribe button. Thank you.